Alrighty, my people. How are we? Okay, more fun with trig problems. Sort of applying what we've learned and what we've defined, and all sorts of fun stuff like that. So let's go ahead and jump right in with this style of problem. It says sketch a right triangle corresponding to the trigonometric function of the acute angle. Okay, acute meaning less than 90 degrees. So we're talking about something in the first quadrant, which means that all the ratios are going to be positive, and that's the whole reason why they gave you that specification. Use the Pythagorean theorem to determine the third side, and then find the other 5 trigonometric functions. Okay. Now, we can go ahead and fill in 4/5 and 5/4 down here before we even draw our triangle. Let's go ahead and draw our triangle. Okay. Now, if we know that, let's call this theta. It doesn't really matter. It doesn't have to be drawn to scale. It just has to be sort of a visual for being able to discern all this fun stuff. This is going to be 4, and this is going to be 5. And if you're thinking to yourself, Pythagorean triple, no, because in a 3, 4, 5 right triangle, the 5 has to be the hypotenuse, because a hypotenuse has to be the longest side. This actually becomes, and we'll call this z for lack of a better name, 4 squared plus 5 squared is equal to z squared, and z squared is equal to 16 plus 25, which is 41, and therefore z is equal to the square root of 41. And so we can scratch out the z and make it the square root of 41. Now that we have all 3 sides, it should be a relatively straightforward affair in terms of discerning all of these based upon the ratios that define them. Sine is opposite over hypotenuse, so 4 over root 41. Cosecant is going to be its reciprocal. Cosine is adjacent over hypotenuse, so 5 over root 41. And secant is going to be its reciprocal. Now, if we want to go ahead and rationalize these denominators, which you have been in the habit of doing most likely, we get those ratios. And let me go ahead and zoom in just a smidge so that you can see it a little bit better. And we get 4 root 41 over 41 for sine, 5 root 41 over 41 for cosine, and their reciprocals, root 41 over 4 for cosecant and root 41 over 5 for secant. So that shouldn't really be all that taxing at all. This one, not too much more difficult, but certainly one layer of complexity on top of that, largely because we know that trigonometric functions, when they are applied to angle measurements, give us ratios, and this doesn't look like a ratio. But you need to remember that it doesn't need to look like a ratio to be a ratio, right? 9 is a rational number. It is capable of being expressed as a ratio of integers, and therefore we can go ahead and draw our triangle. And remember, like I said, doesn't have to be drawn to scale. It just needs to be a visual. It needs to have a place for all of the values. Now, cosecant is hypotenuse over opposite. So this is 9. This is 1. Definitely not to scale. And we'll call this x. We need to use Pythagorean theorem to find x. And so we get x squared plus 1 squared is equal to 81, which is 9 squared, right? And so x squared is equal to 80, or x is equal to, okay, now we know that it's an acute angle, so we don't have to do the plus or minus, and taking the square root of 80 seems like an arduous task because 80 is not a perfect square, but it has a perfect square inside of it, which is 16. So this winds up being 4 root 5, right? Because 80 is 16 times 5, and when you take the square root, you can take the square root of the 16, but not the 5. Okay. So this becomes 4 root 5. Cosecant here is 9. Sine is 1/9. Those ought to be the easiest ones to figure out. Cosine is going to be 4 root 5 over 9. Tangent is going to be opposite over adjacent. So it's going to be 1 over 4 root 5. 1 over 4 root 5. And if I need to go ahead and rationalize that denominator, I multiply it by root 5 over root 5, and I get root 5 over 20. Of course, when I'm turning it into cotangent, I'm going to use this one right here, and it's going to be 4 root 5. Now, when I'm looking for secant, I'm going to put the reciprocal, 9 over 4 root 5, and then I'm going to rationalize and get 9 root 5 over 20. Okay. Now, that should be pretty straightforward. You've done it before. And so I'm going to go ahead and move on to 2 application problems, neither of which are extremely difficult. We'll save those for later. Yay, difficult. And these I stole out of, I forget which textbook, but they're very rudimentary, run-of-the-mill trigonometric application problems based on right triangles. And this one reads, at a certain time of day, the angle of elevation of the sun is 40 degrees. To the nearest foot, find the height of a tree whose shadow is 35 feet long. Okay. Now, 40 degrees is this angle right here. It's the angle of elevation. With respect to 40, that side right there is the adjacent. The height of the tree is the opposite. This, I don't care. Okay? Don't care. Don't care, don't care, don't care. And so I know that if I'm dealing with opposite and adjacent, I'm probably going to go ahead and use tangent, okay? And that means I have h over 35 feet, and therefore h is equal to 35 feet times tangent of 40 degrees. Now, the only difficulty in dealing with problems like this is you have to make sure that your calculator is in the right mode. Okay? Notice that mine is in radians. So I need to go to mode, switch it to degrees, and if you have an Inspire, I am of no help for you. I apologize, but I have never had an opportunity to figure out how to use one of those bad boys. And so you're likely on your own. And this winds up being 29.368 feet. Okay? Now, like I said in the previous video, I want you to get into the habit of estimating, when necessary, to 3 decimal places. And the reasoning for that is very, very specific. That is what they expect of you on the AP Calculus exam. And if you go ahead and get into the habit of it now, you're not going to have a problem later, okay? Now, here's another thing that I'm kind of a stickler about. When I ask you a question in sentence form, I need you to answer that question in sentence form, okay? And therefore, you need to say, the tree is 29.368 feet tall. That is truly the answer, okay? Because that gives this quantity a context. Now, last problem, okay? And this one is actually it's going to harken back to something we were talking about previously. Let's go ahead and read it. A telephone pole is 60 feet tall. A guy wire 75 feet long is attached from the ground to the top of the pole. Find the angle between the wire and the pole to the nearest degree. Okay, well, we've already got our calculator in degree mode. With respect to theta, we just need to determine what our quantities are. And the thing is that we don't even have to use those quantities, because if you notice, both of those have a factor of 15. That's 4 times 15. That's 5 times 15. And 3 times 15 down here is very easy to get. If you want to use, tangent instead of cosine, if you want to use sine instead of cosine, once you have all 3 measurements, you can use whatever you want. Let's go ahead and just use the 2 quantities as they're given to us with respect to this theta. And sometimes it's easier if you just, look at it on its side. This is the adjacent. This is the hypotenuse. So cosine of theta is equal to adjacent 60 over 75. Now you could put feet and feet, but those are going to cancel out anyway, okay? Now, what you need to do now in order to find theta is you need to use the inverse trig button on your calculator, okay? Now, time for a little, I'll explain it after I'm done with this, okay? You're already in degrees, and it actually asked for it in degree, so that's good, okay? Let's go ahead, and we recognize the fact that theta is going to be equal to the inverse cosine of 4/5. So we can do the inverse cosine, so that's second cosine, of 4/5, and that's going to churn out theta is equal to 36.870 degrees. Okay. Now, when you actually answer, because I want this when you figure out theta, when you answer the question, if it actually says something like the nearest degree, go ahead and follow those instructions. And so the angle between wire and pole is 37 degrees, or approximately 37 degrees, however you want to term it. Okay. Now, one thing real quick about this notation right here. Notation is not something that was, birthed out of heaven and fallen to earth. In fact, notation in mathematics has a history of its own. And that means, because it is a product of human invention, sometimes they do it poorly, okay? And this is going to be really frustrating, because when we have sine x squared, that can be turned into sine squared x, right? Because the squaring means the same thing. If I have sine x to the -1, -1 as an exponent means reciprocal, right? It refers to the multiplicative inverse. And therefore, this is equal to cosecant x, because 1 over sine. It is, okay, this is not equal to this. How's that for confusing? Okay. Now, in the beginning, what happened is, because of and you've done rules of exponents, and you have, 1 over x to the n is equal to x to the -n, right? And where negative exponents mean reciprocal, they mean multiplicative inverse. Unfortunately, somewhere along the way, they started to be used in the notation for function inverses in general, okay? And this is the inverse operation of the sine function, not the multiplicative inverse of the sine function. This takes an angle measurement and gives you the reciprocal of the sine ratio. This takes a ratio and turns it into an angle measurement. And so there is a really unfortunate disconnect in terms of some of the notation. This is why I usually don't use this. I usually refer to it in the old school way of arcsine or arccosine or arctangent or something like that. But you need to remember that this is really unfortunate notation, and it does not mean the same thing as this. Okay, it does not mean multiplicative inverse. It means function inverse. Okay. And we'll talk more, and anytime we have sort of a really unfortunate use of notation, I'll try to bring it to your attention, because the last thing I want to do is have you understand the mathematics, the concept, but be mistaken because of the ambiguous notation that was invented 300 years ago. Now, if this had happened and they had asked me, I would have said, that's a bad idea, guys. But unfortunately, I was not invited to that party, and I was not consulted in that decision. So I just need you to be mindful of it, okay? That's it, guys, for right triangle trigonometry, day 3. We will do things that are very similar to that, but sort of extending them, and it's basically usually in textbooks, the section is called trig values of any angle or something like that. But we will basically take what we have learned in 4.3 and sort of amplify it. 4.3 is just the numbering from the textbook where I'm sort of getting my outline for this one. We will take those principles and we will amplify them on day 4. Okay? Bye, guys.